Hi, this is Miss Sam. And transformation. In symmetry, we will learn reflectional symmetry, rotational symmetry, and we will go over some regular polygons as well. Let's start. Here you can see some figures. So for a plane figure, a figure that is fell along a straight line like this. And you can see two sides of this figure coincide completely. That means overlap completely, equal on each half, okay? So this figure equal on left, right. And the last one, equal up, down. And they all have the reflectional symmetry. While the blue dotted line is called the axis of symmetry. Sometimes you may see figures that may have more than one axis of symmetry, like the letter H on the left. There are two axes of symmetry. You can cut it up, down, equal. You can cut it left, right, equal. And while the blue cross on the right-hand side, you can cut it up, down, along the diagonal, or left, right, or along another diagonal. So there are four axes of symmetry. Okay. Let's have the first example. The following figures, which one or which figures has or have reflectional symmetry? If so, draw all axes of symmetry. Let's think. Well, here comes the answer. You may note that A, B, and C, they have reflectional symmetry. And while their axes of symmetry are the following. And the second example, okay? Here I now give you two isosceles right-angled triangle of same size. Can you use this tool for two figures that have reflectional symmetry? Let's think for a few seconds. Okay, shows you the first one. Along this, you can cut it into two equal halves. And you can form in this way. So along the diagonal, you can find these two are equal as well. So they both have reflectional symmetry. Can you think of other figures? Here they are. Girls, I think you may have your own figure. So let's try. Use this two. Form your own pictures. Then the next goal is rotational symmetry. Rotate means turn round. A complete revolution, 360 degrees. About a fixed point, say as this one. If I hold this point, fix it, and try to rotate it. And can you see the yellow dot that rotate, turn around 100 degrees? And you can get the same blue rectangle. And another 180 degrees. So you get the same rectangle again. And this point, the fixed point is called center of rotation. And in one complete revolution, 360 degrees, I can get the same rectangle 2 times. So I call this as two-fold rotational symmetry, or called the order of rotation symmetry. If 2 times, that is 2. Okay, let's try the following 4 figures. See how many fold, or the order, how many, okay? The first one, turn it 180. You get it once, turn it another 180. That's a 360. You got 2 times this figure. So it is two-fold rotational symmetry. The second picture, rotate it and form a complete revolution. You got the figure 3 times, so this is three-fold rotational symmetry. The third figure, in one complete revolution, you got the picture 4 times, so 4-fold rotational symmetry. And the last one, in a complete revolution, you got 5 times the same figure. So this is a 5-fold rotational symmetry. Then the next one, here you can see 3 figures. And which one or which figures that have refractional symmetry? If so, draw all axes of symmetry with dotted lines. And which figures have rotational symmetry? If so, just mark the center. Let's think. The answer, the figure A that has refractional symmetry only, with no rotational symmetry. And this dotted line is the axis of symmetry. Figure B, it has rotational symmetry only. You can only rotate it, turn it around. Center, and the order is 2. And the last one, it has both refractional and rotational symmetry with 5 axes of symmetry. And the order is 5. You can turn it around and get 5 times the same figure in one complete revolution. Okay, the last one, it is regular polygons. Girls, can you tell the definition of regular polygons? What kind of polygons we call regular? Let's study the following figures. Or you may guess from these figures. Regular polygons means the polygons that have both all equal angles. The angles are all equal. And all equal lengths. All their lengths are equal. So for equiangular and equilateral, then the polygon is called regular. Okay, study the following regular polygons. Can you tell the number or size of each one? And can you tell the number or axis of symmetry of each figure? And also the order of rotational symmetry? Let's think. The first one, look for the axis of symmetry. You can see there are 3. The second one, there are 4. The third, what figure is this one? It's a hexagon, 6 sides. So, how many axes of symmetry? Let's count. So, can you get the number of axes of symmetry? And the last one, what shape is this one? How many sides are there? It's an octagon, 8 sides. So, how many axes of symmetry? Let's count. Okay, so can you get the answer here? Check your answer. And you can see for the number of sides of it, then the number of axes of symmetry, and the order. So we can draw the conclusion that a regular, say, 4 sides, then it has 4 axes of symmetry. And it has also n-fold rotational symmetry. Let's go back to the last question. If it is a 6-sided polygon, then there are 6 axes of symmetry. And 6, the order of rotational symmetry is also 6. Understand? So that's all today. See you next time. Bye-bye.